So the way that arrays are arranged in memory is that each cell is right next to one another. So every element in the array would be right next to the other elements in the array. They're arranged in a straight line. And 2D arrays, arguably, they're also arranged in a straight line. However, it's easier to think of them as a matrix. So the number on the left hand side, M, as you can see here, would represent the number of rows, and N is the number of columns. The number on the right is the number of columns. So even multi-dimensional arrays, they could be laid out as a straight line in memory. However, it is still easier to think of them as a matrix. Some of the advantages to arrays is that they're very organized, and dynamic arrays, they're easier to resize. So in the case that you need to place more data into an array, it's easy to resize it and you don't go out of bounds in the array, you don't get an error. They're um they're much more efficient because you are using pointers. You're pointing to an address in memory. The compiler runs a lot more quickly because you don't have to run through every single element in the array just to find the element that you're looking for. You don't have to run through every single index. You can just find the element, and you can find the element and you can find the array based off the address in memory. It's very efficient random access, which would actually be some of the disadvantages, though, would come more with static arrays, because static arrays, they are not resizable, and again, static arrays are going to be you aren't using pointers for them. So if you want to find the array in memory, you're going to have to go through the whole program in order to find the array, and that makes the compiler run a lot more slowly because you aren't given a specific address to go to at compile time. They also haven't, they're not easy to resize, so it's easier to go out of bounds. And if you want, and that just makes even that wastes memory, because if you want to use a static array and input lots of data into that static array, you will run out of space, and you may run out of space, and you also can't, because you cannot resize it, you have to make the initial size of the array very large in order to avoid running out of space too quickly. So not all of those cells in the array will be used, meaning that you're just wasting space in memory. But now to my program, the question for question 2 was that we will be given two integers, m and n. M will be representing rows and n is the columns, and we need to create a 2D array. I created a static array, and we will input m times n values into the array. So I prompted the user to enter a value for m and enter a value for n, and I created a nested for loop in order to enter every entry, so that I could input a number into every entry in the array. And here, this is how I output it. I also outputted using a nested for loop, making sure that I placed the brackets in the correct places. And if it was the last element in a specific array, well, for a 2D array, every row is an array itself. So I made sure that in the inner loop, I tested if it was the last member in the array. Then if it was not the last member in the array, then I would output a comma and a space. And I made sure to do the same thing in the outer loop, so that I made sure to do the same thing in the outer loop so that I could output the brackets in the correct spaces, and so that the rows would actually so that the rows would show up on the same line instead of in matrix form. So if I put in if I run the program, I put in a 2 by 3 matrix, I will enter a value for each entry. I get this output. And then I also created another program for question 3, which is just derived from that program from question 2. So we were given integers m and n, m again represents the rows and n represents the columns. So I created a dynamic array. So I created a dynamic array named dar, and I requested new memory from the heap of type float, and new memory from the heap of type float for the amount of rows. And then I created a for loop to request new memory from the heap for every single column. And then in order to input floats into each cell in the array, I did a nested for loop. A nested for loop, I representing so I is going to be the loop for the number of rows, and j is going to loop for as many as there are columns. And in order to output the transpose, since transpose, I have to switch the rows and the columns in this nested loop. I is now going to be looping for the number of columns, and j is going to be looping for the number of I is going to be looping for the number of rows, and j is going to be looping for the number of columns. And again, I outputted a space in the in the inner loop, I checked to see if the number still was not the last entry in the array, then I would output a space. And then in order to release the memory, I made a for loop to delete every single element in the array. And then I made a statement outside of that for loop to delete the array itself, the whole array. So when I run the program, I'm going to when I run the program, I'm going to enter a 2 by 2 matrix. So it's going to be 1.0, 1.1, 1.0, and 1.1. And this will be my output. Thank you for your time.